Right, so let's do an example of the one sample hypothesis test here. Okay, let's read through this example A. It says a sample of 54 cans, that's a sample size, a sample of 54 cans of soda have a mean amount of soda of X bar equals 12.05 ounces. So this is the sample mean of the 54 cans. On average, the 54 cans together have about 12.05 ounces of soda in each one. Assume the contents of cans of soda have a normal distribution with a standard deviation of sigma equals 0.21. There's our population standard deviation. Conduct a one sample hypothesis test, and that's what we're doing here, one sample hypothesis test, to determine if the sample data are significantly different than. Note, this does not say significantly higher than or lower than or more than or less than. It says different than. This indicates a two-tailed test. This indicates a not equal to alternative hypothesis, okay, are significantly different than the population mean of mu equals 12 ounces at the 0.01 level of significance. So 0.01 level of significance, that is our alpha, okay? All right, so let's go through these one step at a time. Let's do step one. We're going to identify our null and alternative hypotheses. Our null hypothesis is that mu is equal to 12 ounces. And so because this says do a one sample hypothesis test to determine if the data are significantly different than, that's why we chose a two-tailed test. We chose not equal to, okay? Now, step two, we're going to identify a bunch of things. We're going to identify the sample size, which is 54. We're going to identify the sample mean, which is 12.05. And then we're going to also identify the population standard deviation, which is 0.21. It's all in the question. We're going to identify mu, which is in the null hypothesis, mu equals 12. And so now with that information, we also want to identify the alpha, the level of significance, which is right over here, 0.01 level of significance. And we're going to state our p-value rejection rule. We're going to say reject H sub O if our p-value, p, is less than 0.01, okay? All right, now step three says to identify the critical value of the test statistic z, which we're going to do in NumWorks. We're going to go to the NumWorks calculator. We're going to go down to distributions. We're going to select normal distribution. We're going to leave it mean is 0, standard deviation is 1, hit next, okay. And since this is a two-tailed test, we are going to go down to the right tail test. And we're going to go all the way over to the right, and we're going to put in alpha divided by 2. So remember, when it's a two-tailed test, okay, when it's a two-tailed test, when we're going to identify our critical z value here, we have to enter alpha divided by 2, which in this case is 0.01 divided by 2. And 0.01 divided by 2 is 0.005. So this is the number that we're going to put in to the NumWorks calculator. So we're going to go all the way to the right over here. We're going to put in 0.005, execute, and then we get 2.575829. Now remember that it's a two-tailed test, so we need the positive and the negative version of this. So 2.575829. Okay, so it's going to be plus or minus 2.575829. Okay, and we can get rid of these notes here. And so now we have to state our rejection rule for the critical z. We're going to say reject H sub O if the absolute value of the z statistic is greater than just the positive version of this, which is 2.575829. 0.575,829. Okay. All right. Now moving on to step 4. Step 4, we're going to calculate the standard error and the z statistic. Okay, so the standard error is going to be sigma, which is 0.21, divided by the square root of sample size, which is the square root of 54. Let's go over to the NumWorks calculator, and we'll go to the calculator part, and we'll put in 0.21 divided by the square root of 54. And that gives us, we're going to go out 6 decimal places, 0.028577. 0.028577. 0.028577. And then to calculate the z statistic, we're going to do x bar, which is 12.05, minus mu, which is 12, divided by the standard error. So we could put 0.028577 under here, but I'm going to go ahead and put in the full formula, which is 0.21 over the square root of 54, and then go back to the calculator and do this. We're going to do parenthesis 12.05 minus 12. We did this in a previous video. Divided by, we're going to do 0.21 over the square root of 54, and so our z statistic is going to be 1.74963, and we'll make this one a 6 based on this 5. This 5 will round this 5 up to a 6. So 1.749636. 1.749636. Now hopefully you can see already that this is not larger than our critical z value. So I can already see we're not going to reject, okay? And so in step 5 now, we are going to identify our p-value. And to identify a p-value, we're going to go into the NumWorks calculator, and we're going to go to the distributions. And since this is a two-tail test, we're going to use the right tail, okay? And in here, in the middle, that's where we're going to key in our z statistic here, 1.749. So 1.749,636, and then that equals 0.0400957. Now, I want to remind you that in a p-value, we have to multiply this number times 2 because this is only one of the tails, and we actually have to put it in both of the tails, okay? And so we're going to multiply this by 2. So we're going to do 0.0400. I'm going to grab a different calculator. You can't see the one that I'm using, but 0.0409057 times 2, and that gives me 0.00801. So 0181. Okay, there we go. And so now we're going to make a decision. Okay, so we can see clearly that this p-value is not less than 0.01. Okay, and so therefore we are going to say do not reject H sub O. And then we have 2 reasons. Okay, the first one is because P is actually greater than 0.01, and the other reason is because our z-score here, which is the absolute value of z, is less than 2.575,829, okay? And so both of our rejection rules, we reject H sub O. If this is true, it's not true. We reject H sub O. If this is true, it's not true. So we do not reject H sub O. The last step we're going to do is we're going to do a confidence interval. And the way we're going to do the confidence interval is we're going to do, we have to do X bar plus and minus. So plus or minus, we got to do both of them. The Z star times the standard error. Now this z star times the standard error, that gives us the margin of error. Okay, so let's do that. Our z star here is 2.575829, and we're going to multiply that by the standard error, 0.028577. So we'll go over here to the calculator, and we'll do 2.575829, 2.575829 times the standard error, which is 0.028577, 0.028577. Execute, and we get 0.073609, 0.073609. So our x bar here is 12.05. We're going to subtract and add this number here, 0.073609, 0.073609. So first we're going to do 12.05 minus 0.073609, okay? So do 12.05 minus 0.073609. And that gives us 11.976. We'll stop at 11.976. So we get 11.976 less than or equal to mu less than or equal to. Now we're going to do 12.05 plus this number. Okay, and we can actually do that by going up to this one that we just used and hitting enter, and we're going to come over here and we're going to change this minus to a plus and then hit, we get 12.124 and 12.124. And now look at our mu. Our mu all the way over here is 12. 12 is between these two numbers. 12 is in there, and because 12 is on the interval, we do not reject H sub O. Okay, and all we've done here is we've just used a confidence interval to confirm that we will not reject the null hypothesis. Okay, so there is one example of a one sample hypothesis test. You'll see another example in the next video.